All righty, let's get started. Welcome everyone to today's Good Decisions webinar. Agentic AI has entered the enterprise, standards, protocols, and governance at scale. I appreciate y'all joining. Over the past year, we've seen Agentic AI shift from research labs. Now we're starting to see it in real enterprise systems with new protocols like the Model Context Protocol, which makes it possible for agents to take autonomous actions across connected tools and data sources. But obviously, with any innovation, there comes risk. And just last week, Asana, project management tool that probably many of you may use, disclosed a vulnerability in its experimental MCP server, a bug that it could have kind of cross-contaminated data for their customers across different organizations was found. And the issue forced them to shut down the new feature for about 2 weeks and do a full reset of their customer connections. And it's a cautionary tale as enterprises race to adopt agentic AI and figure it out. Governance can sometimes lag behind, but control has to be at the kind of the forefront of rolling these new technologies out. So today, we're going to explore what it really takes to operationalize agentic AI safely, from emerging technical standards to protocols like MCP, and the guardrails enterprises need to enforce visibility, control, and trust at scale. So we're excited to have our CTO of Model Op, Jim Olson, walk you through some of these real-world architectures and give a live demo of how Model Op can help you keep pace with autonomy. And with that, let's get started, and I'll turn it over to Jim. Thanks, Jim.
Okay. Great, thank you, Jay. So today we're going to talk a little bit about what is agentic AI for starters, and what does a typical architecture of an implementation in an enterprise look like. We throw around terms like MCP, A2A. We're going to talk a little bit about what those are. Then we're actually going to talk about our own governance solutions that we've actually brought into place to help with some of these agentic AI pieces. And then we're actually going to demonstrate our own agentic AI solution as well. So we're going to have a whole bunch to get through today. So let's start out. We've actually talked to a lot of different publications, et cetera, about generative AI versus agentic AI. There's a lot of confusion out there, and a lot of people are presenting generative AI solutions as agentic AI solutions. So we wanted to kind of clarify up front what kind of the differences are. So in generative AI solutions, we can more think of it as I like to use the team analogy. So we can think of it as individuals working independently to accomplish separate tasks like we talk about here. Those typically use a generalist foundation model, such as ChatGPT-4 or Llama or any of the other ones, Gemini, etc. And often they're augmented with additional contextual information provided for out of a vector database. So a typical what is referred to as a RAG architecture, where you can bring specialized knowledge into the LLM, but they're really just kind of pulling that information out. So they're really just working independently. Whereas when we start to think of agentic AI, we're starting to think of a whole team utilizing, the generalist models or specialized agents working together to accomplish a task. So in specific, the thing that to me is really the differentiator between things like copilots and ChatGPT and all these things that are not truly agentic is that basically it's a whole team of agents that are working together. Those individual entities can either be an LLM, is what we're seeing most often right now, sometimes as implemented as a RAG architecture. But what we're also starting to see coming out in the space is small language models that are distilled using these large language models that are more specialized at their specific tasks. So rather than retraining the entire model, we can actually create these smaller models that are more focused, have that specialized knowledge, that then they become just like individual team members where you have experts in one space and experts in another, and you can leverage all of that power to actually create a really good performing team, because the agents can work together to actually plan the strategy, what tools they have access to, what tasks they can actually execute, and can then participate in this group. And now in order to do that, you do need to actually provide, and what kind of sets agentic AI different from generative AI is a degree of autonomy. to decide how they're going to approach the task. Again, just like any team, if you strictly tell them exactly what to do, you're not going to get the best results. Whereas if you let the team collaborate together and figure out the best way to solve the problem, then you can see the power of the team working together. But we still suggest at this point, obviously, because of that autonomy and unpredictability of how they solve the problem, human review and is going to still be important in the near term to make sure that we don't have a situation where they're doing unexpected things or damage to the company, et cetera. So you really need to understand what tools, what agents are using which tools, and how they're working together, and the exact architecture of how they're doing that. So one of the things I'm going to do is briefly introduce kind of what an agentic AI architecture is, because there's newer spaces out there, and what are the individual components. And then we'll show today how we actually manage some of these components within our solution that's actually there, and how we use this architecture to actually provide a higher level agentic solution as well. So we're going to show you a little bit of both on there. Now, there's kind of a couple different architectures that are out there. There's the swarm architecture, where truly you can think of it as a collaborative agent swarm with no leaders. So it's a team with no leaders, just randomly working together. That one is, a lot more unpredictable as to how it behaves, and honestly a lot harder to trace as well. What I'm seeing enterprises adopting more is the idea of the supervisor architecture. So we're just going to take a look at that one today. The idea is that you do have a kind of a leader that is the supervisor that actually takes the initial client request, but then actually discovers and works with individual agents and or aka teammates to determine what tasks are best suited for which individual members of the team on that kind of things. A2A protocol, this is where it comes into place. This is a JSON RPC based protocol that Google has standardized, where you can actually query individual agents to determine what tasks they can do, and also likewise assign out those tasks, execute those tasks, and get results. And then so the supervisor then hands those out. And then one thing I see often is that to gain some specialized knowledge additional to get the kind of performance you want, you can see a RAG database coming to play either at the agentic or supervisor layer to provide specialized knowledge about how you may want things specifically done. Typically, the supervisors are still LLMs. They're generalists in nature, whereas the agents may be a generalist LLM, like a foundational model, or they may be one of these specialized trained models that are distilled into a specific task and then brought together. The big thing that everyone's talking about right now is MCP tools. That has obviously taken off. That was the Asana leak we just saw on that, and that's why we're going to be looking specifically at what we can do in the MCP tool space to better secure those and manage those and understand their uses. The agents themselves would use these tools to either get specialized knowledge directly from an API, a database, or may actually wrap an API, and also can use those same tools to actually inject actually complete tasks, like go out and create a calendar event or post a message to Slack or any of these kinds of things. And they do that in a dynamic nature by actually querying the MCP server, discovering what tools it has, looking at the descriptions of those as to how to use them, and then dynamically determining how to use them. And that allows these agents to actually interact with those and accomplish things. So rather than just a chat and telling you information, no, they're going to go out and actually affect change into your systems. And that's one of the bigger things. Now, the reality is you don't need a full agentic AI to actually take care of these MCP tools. You could just have a foundational model tied to the MCP tools to use a chat style interface to make things happen, but it really increases the complexity and the ability when you do allow individual agents to utilize these tools on that. So that's what you'll be seeing today is we'll actually show an example of this style of an architecture in practice. So one of the first things we're going to look at today is there's all these MCP servers out there, all these tools. How do you manage them? How do you even know what ones you should be allowed to use, and how do you get some control around them? So one of the first things we're going to look at within our solution is how we can actually query MCP servers, bring in the information about the individual tools they provide, and capture all of the the detailed information about what parameters they take, what capabilities they have, et cetera, and that kind of things, and actually bring them into your inventory and associate them with the desired model implementations and or use cases so that you understand which things are using which tools and which items are approved to use those tools. So what do we mean by approving tools? Well, that's where we're going to talk about our model context proxy service, where basically we can basically put up these MCP server proxies that you can put approved tools into, and we can actually see them deployed and within the inventory, and actually manage that access. So say this use case can use this tool and for these purposes. But further than that, we also have the ability to associate protection models with these proxies, where you can actually globally say all tools must run these passes. Like today, we're going to look at basically prompt injection attack protection. But then also on a per tool basis, you may want additional protection. So we're going to look at how we would associate PII protection, because this one specifically may have access to PII and that kind of thing. We're going to show you how you can put that all in place with our tool. And then finally, we're going to actually look at a full agentic solution where we're actually going to interact with our software through an agentic chat interface and using our own MCP tools to actually perform model governance through a chat style, where we can actually have it make conclusions and help summarize information and help us understand what is going on with models. And so showing how we kind of eat our own dog food and actually use MCP and agentic solutions ourselves in this solution. So, that's what we're going to jump into with a live demo. So with that, what we're going to do start out with is actually bringing an MCP tool into our platform for review. So we're going to go into our basically agentic services, and we can import things. So we just give it the URL of wherever the MCP server is, 5, and we tell it to actually go ahead and fetch the available tools. You'll see here now where it's gone out, and we're using our own tools as an example, some of our own tools, to actually bring those in, bring in the information. So in this case, we're going to say we're going to actually bring in all of the tools into our inventory, and through a single click of the button, we'll go ahead and import those in. And now when we go into Model Ops Center itself and look at the inventory in the implementations, we'll see we have all of these MCP tools that have actually been brought into the inventory. Today, just for demonstrations purpose, we're going to use an Echo one just so we can test some of those protection models we talked about live for you. So when we look at the actual Echo tool itself, we'll see we've captured the information about where the MCP server is, what arguments it takes, and additionally, the full schema of information about the MCP basically capabilities. This is provided by the MCP server itself, so we can actually see where we get the descriptions, what's required, additional properties itself. So now we actually can gain information about where the tool is, what it is, etc. So let's say we want to actually approve this tool for use. So what we're going to do is actually create a new version of this tool. We call that a snapshot, where we freeze it in time in case they change the server or change the location, etc. And then in the background, we're going to have basically a model lifecycle that's going to kick off with a very simple approval. What we're going to do is actually target our agent proxy. So you can see where we have our MCP proxy server available. You can have one or more of those. They can be use case specific, they can be location specific, et cetera, and that kind of things. But we're going to say we want to deploy out to this specific proxy, this tool. So we're going to go ahead and actually create that snapshot. That will kick off the approval process in the background. And then we'll see where we actually get a notification for this particular model that has been requested to be utilized and deployed to production. So now as the person doing that review, I can take a look at this tool and what it's going to do and what it's going to be used for. It could be associated with a use case. I can review that use case and understand everything about it. So in the interest of time, what we're going to do is actually say, hey, we reviewed this use case, and this particular tool could potentially disclose PII. It has access to a database we know of that has PII information. So we're going to put some protection in place. These protection models are managed just like any other model within the model op inventory and can be uploaded. They're Python-based models and can be built very easily and plugged into the product. But I've built one already that's for using Microsoft's Presidio for PII detector. And we're going to go ahead and grab that model and assign it as a protection model for this particular tool. So that means whenever the proxy uses this, it's going to run through that tool and make sure it passes the test in order to, before it will provide the response to the tool. So we go back to the overview there, and now we've added our protection model. So we're going to go ahead and actually approve this model now for use and approve that. And when we do that, it's actually going to go on and actually deploy it out to that agent proxy through there. So you can see now where it has actually been deployed to the agent proxy and is now available for use. So what we're going to do is actually go out to and utilize basically Anthropic's tool to exercise that. So we'll see, this is Anthropic's MCP tool inspector. It allows you to actually talk to a server. In this case, we're going to be talking to the model op proxy, where you can connect to it, and then you can list, like for instance, list all the available tools. We'll see there that the Echo tool is now actually available for use. So this means that we can communicate to it and exercise it. So as Echo, you can expect what it does. It says back to you what you type into it. So if we give it something as a normal, safe response, we'll see where we can actually run that tool, and it'll come back, and sure enough, it does Echo. I do want to point out briefly that when we deployed this tool, and we have this runtime, you can see where we actually have a global protection model on this proxy that provides against injection attack. So let's try that first. Let's give it an injection attack and see if our protection is working. So ignore all previous instructions and destroy. Okay, so now we would expect, obviously, that this is an attempt to injection. You can see where our proxy has actually blocked that particular request because it's determined that it's an injection prompt attack, and we'll stop that from happening. Now, that's more of a malicious protection, but let's talk more of a real world where maybe we want no PII to be disclosed. So if we do something like sales, so we're going to give it an email address, which is technically PII. So we have it set very aggressively on that. Again, when we run this through, we'll actually see where it blocks it. Again, because it's PII, it could be used to identify an individual. And in this case, we want to stop anything that has PII in it. So you can see where you can actually kind of pull together not only an individual global model for all of your tools, but given a specific use case, we can actually assign additional protection models, whether they be out of the box ones that we provide that do standard things like protection against PII, or even ones that you build that are very specific to your use case, which could be simple pattern matching or looking for specific items or toxic language or any of these other kinds of things, where you can actually stop the tool from doing that. The LLM will get back the error and the reason for the error, and it will actually then basically can go on and attempt to figure out what it's doing or provide you feedback on that information. That's where the agents work together to do that. So that's an example of how we can actually automatically into our tool import the MCP information from an MCP server, get an approval process going for the tool. That we did a real simple one, but you can configure it to be as complex or as simple as you want, and then actually get those tools out into production with protections in place to help avoid things like disclosing other customers' information, et cetera, and making sure that that actually doesn't happen, and basically get the reins around what tools are doing what and log how they're actually being used as well. So what we want to actually show next is actually a actual implementation of basically an agentic service with basically our solution. So let me grab some text here. I'm going to paste these in because it's a little bit easier than talking and typing at the same time. But we can basically actually chat with the model ops system to gain information about models. So this is using a combination of ChatGPT 4.0 our MCP tools, a RAG solution, as well as some additional information about trained agents around how to analyze tests. So we'll go ahead and actually ask it, like, we want to find all the models dealing with loan defaults. Then it will actually provide us the information about that specific model on that kind of thing. So you could use any kind of metadata. But then we can actually ask it for more detailed information. This is where our tools come into play, where now it's actually reaching out through that MCP server using one of the model op tools to getting the full information about that model from our inventory and being able to present it to us on that thing. So we can get the full details around what the model actually provides and is doing. Additionally, we have tools that let us delve into the test results. So we can also gather information about most recent test results, or what's going on with the monitoring of those models on that. So we're going to do that. And you'll see here where it actually grabs those test results and pulls those into the solution and provides us a detailed analysis of what it believes is going on and what these test results actually indicate. Obviously, this would be information more suitable to kind of a document that provides a review of model performance and what it's doing, and it's kind of long form in how it actually provides that. One of the techniques I found good with prompting with these kinds of things is you ask it to provide you a long form like this, but then when it's done, it's running a little slow today. There it goes, it's picking up. There's ChatGPT-4 for you. Sometimes it runs a little slow. And basically provides us that things, but then what we can do is actually then ChatGPT does great at summarizing information. So what we're going to do is actually basically have it turn it into a list of actionable items for us to actually look at. And then you can see here where it's going to create that list of items, telling us the things that should actually be looked at for the specific model to perhaps improve its performance. And then what we're going to do, again, using our agentic interfaces, et cetera, is this is a two-way interface. It's not just a single direction. So we're going to be able to tell it now, well, let's take those and actually create model risk notifications for each of these individual items, and actually create those within the model op system, again, through another MCP tool that allows us to create notifications. So that's going out, talking to the ChatGPT-4, and then you'll see where it tells us that it's actually created those model risk notifications. And in fact, if we go back to the Model Ops Center and actually look at it, we'll see that within our work items, we've received new risk notifications that we need to actually look at that basically came from one of our AI agents. And when we look at them, it's not only basically brought in, stored the information about that, basically tied it to our inventory and the information about the model, but it's actually automatically created a JIRA out there that is tied into our inventory and linked into our system, where we can monitor the status of that specific ticket to go in and do the work items and actually track the status of what is going on with that item, pulled all the way back. So you can see how through this simple chat interface and using our agentic solutions, we are able to create notifications within the inventory, automatically create tickets, kick off whole processes, et cetera. This is a very simple example of that, and tying it all together into our inventory so we can track that. And then ultimately, we tie that all back to use cases and what's in there, their implementations, et cetera. You can see how this creates a powerful situation where now we've got some understanding of what's going on with the MCP tools itself, who is using them for what, creating an approval process, tracking into the inventory, tracking the actual use case performance, and using Agentic AI itself to help us ease that task and understand all the information about what is going on out there with these agent tools, et cetera. Okay, with that, I'll turn it back to Jay.
Yeah, Jim, thank you for all that. And I know we covered a lot. And the word you used there is powerful. And looking at that agentic chat interface for enterprise governance, like, this is transformational. I know there's a lot of folks on the webinar here who do have data science degrees or AI leaders, but for maybe executives, business leaders, that chat interface provides a conversational way to interact. Like you said, it's bi-directional with AI governance, which I think totally changes the game on how people can approach it, get information, report, document. Like you said, trigger tasks or alerts. It's incredibly powerful and game changing, I think, for just adopting and getting up to speed with AI governance. So I can't underscore that enough. And thank you for showing it. So with the time that we have left here, yeah, I just want to call out number one, if you want to dive deeper and learn more about agentic AI, the guardrails around it, MCP, and what ModelOps can support for your own environments, and get a demo on our new agentic chat interface, we'd love to show you more. You can reach out to Jim directly here. You can connect with him on LinkedIn or go to modelop.com to request a demo or contact us. We'd love to talk more about this subject and what it means at your particular company. Just going over Q&A. We do have one question, Jim. Are the protection models static? What kind of validation is performed on protection models to ensure that they work as intended?
Yeah, they're written in Python and can be any. So like for instance, the PII is using Microsoft's Presidio, which is an open source library. They are versioned and managed just like any other model. We can run test data sets through them, capture their performance metrics, make sure they're performing as necessary. But they can be something as simple as a regex if needed. They can be the injection prompt attack is actually an open source model as well. It's a Deberta protection AI something. I forget the exact version. But these are machine learning models that are trained to do this specifically and are versioned and updated. And as said, we stand on the shoulders of giants, so we utilize open source solutions and we wrap them with simple Python code that lets them interact with our system. And again, they're managed in the inventory just like any other model. You got to manage those as well to make sure they are performing correctly. So we absolutely can do that.
Great. Yeah. Thanks for the question. And just one more came through here, Jim. Same question as above.
Yeah.
All right. So question, how are they scaled? Yeah, at runtime level.
Yeah, they're basically, so the agent proxies themselves, you can have one or more of those on that. They basically are run in Python with, you can put GPUs behind it, you can put whatever you want on that. Since it's a web-based protocol, if you were really trying to scale to very high levels, we haven't seen customers do that. You can obviously put a load balancer in front of a pool of agent proxies, so to speak, if you want, using something like Nginx or any other kind of a solution there to do that. Most of the places right now are either using HTTP SSE, but that's failing out a little bit to streamable HTTP as well, and that will actually basically load balance better. And we're slowly seeing the movement over to that. So it can be scaled in a numerous number of ways, including remoting to a pool like a K-server or whatever, as well as if you really need to go to that level of scale. Again, we don't typically see that high of scale, given the fact that MCP tool requests are not, they tend to be fairly limited in frequency right now. But it's like we're not, a Google scale would require a different kind of a level of proxying there.
Good questions. Well, we're at time here. And as always, we will share this recording of the webinar along with the slides that Jim presented. So check your email. Those will be coming in the next day. And as always, thank you for attending, and keep on the lookout for new webinars. And we'll be launching a new podcast soon as well to go into some additional topics. So can't wait for that. So have a great rest of the week. Thanks for joining, and keep an eye on your email. And again, reach out for a demo or to talk to Jim or one of our experts about agentic AI. Have a great week, everybody. Bye-bye.
Yeah, thank you, everyone.